Hello dear students of medical and non-medical respected teachers. So today I am going to discuss applications of Gauss theorem. So Gauss theorem दी चार applications है, लेकिन आज दी इस वीडियो में सिर्फ दो application discuss करूँगा, दो application next video discuss करूँगा ताकि तानु वीडियो ज़्यादा लंबी ना होवे, तानु difficult ना लगे. So let us start with first application to find electric field due to an infinite charged state wire. Suppose we have an infinite straight wire which is positively charged. Let lambda is equal to linear charge density of the wire, means charge per unit length of the wire is given, and Q is the total charge on the wire. Then consider a cylindrical Gaussian surface of length L and radius R due to symmetry. Let this is a small area element ds vector, small area element ds vector, and third area element ds vector on respective areas S1, S2 and S3, because we have three types of areas, two circular areas and one is curved circular area of the cylinder. Now at this point electric field and area vector will be perpendicular to each other. Similarly at this point electric field and area vector will be perpendicular to each other, and at this point electric field and area vector will be in the same direction, because electric lines of force are always normal to the wire. The wire is infinite, so electric lines of force will be outward from the wire, that is along the radius of the cylinder, radially outward. So in this case for S1 area and S2 area, angle between E and DS is 90 degree. So it means there will be no electric lines of force through these circular caps. Electric lines of force will only pass through the curved surface of the cylinder, because angle between E and DS is 0 degree. So then we can calculate total electric flux phi. By definition, it is defined as closed surface integral of E dot ds is equal to, now we have three separate areas S1, S2 and S3. So we can separate this closed surface integral into three surface integrals. So surface integral over S1 E dot ds plus surface integral S2 over E dot ds plus surface integral S3 E dot ds, because electric flux is always added, or phi is equal to, now angle between this EDS over S1 and S2 is 90 degree, so it will be EDS cos 90, EDS cos 90, and this will be EDS cos 0. So cos 90 is 0, cos 0 is 1. So therefore we have phi is equal to 0 plus 0. This is 0, this is 0, and this will be E can be taken outside because E is constant at that point. So surface integral ds. So surface integral ds is given by 2 pi RL. That is area of the curved surface of the cylinder. Circumference 2 pi r into L. This will give you area of cylinder of the curved surface. So phi comes out to be E into 2 pi r, equation number 1. Now by Gauss theorem, because we are using applications of Gauss theorem, so phi is equal to Q upon epsilon naught. Total electric flux is equal to total charge divided by epsilon naught. Epsilon naught constant of proportionality, and its value is known as permittivity of free space. So equation number 2. So comparing 1 and 2, so we get E into 2 pi RL is equal to Q upon epsilon naught, or E is equal to 1 over 2 pi epsilon naught R Q upon L. What is Q upon L? Lambda, linear charge density, charge per unit length. So we can write E is equal to lambda upon 2 pi epsilon naught. So which is the required expression for electric field due to an infinite charged state wire at a distance r from the wire. So E is equal to lambda upon 2 pi epsilon naught R. As lambda is constant, so it means E is inversely proportional to R. So it means electric field decreases as we move away from the wire in any direction. So this is electric field due to state wire which is charged. Second application, electric field due to an infinite thin sheet of charge. Infinite thin sheet of charge means we are taking single layer of charge only, because sheet is infinite thin, infinite, and it has infinite dimensions and it is thin. So suppose this is the infinite thin sheet of charge. Again, let sigma is equal to surface charge density, which is defined as charge per unit area. Surface charge density of the charge sheet. Q is the total charge on the sheet. Again, consider a cylindrical Gaussian surface due to symmetry. Again, we have three different areas, S1, S2 and S3. But in this case, at S1 and S2, electric field and ds vector will be the same direction. At S3, electric field and ds vector, area vector will be at an angle of 90 degree, because again electric lines of force are always normal to the charge sheet. So it means there will be no electric line of force through the curved surface of the cylindrical Gaussian surface. In other words, electric flux through the cylindrical Gaussian surface will be zero. There will be flux only through the circular caps. So again, by using definition of electric flux, phi is equal to closed surface integral E dot ds. We can split this closed surface integral into three integrals. First over S1, S2, S3, E dot ds, E dot ds, E dot ds. Now, angle between E and ds is 0 for surface S1 and S2. So it will be EDS cos 0, EDS cos 0, and for surface S3, it will be EDS cos 90. Cos 90 is 0, cos 0 is 1. So we have E is equal to E ds surface integral plus E ds surface integral, or it will be ES plus ES. Because we are taking small surface area, circular area, so it may be sheet is infinite. So let S is the total area. So surface integral ds will be S. So it will be 2 ES. So phi comes out to be 2 E into S. S is the total circular area. Then by Gauss theorem, phi is equal to Q upon epsilon naught again. So comparing 1 and 2, so 2 ES is equal to Q upon epsilon naught, or E is equal to Q upon 2 epsilon naught S. Now Q upon S is again sigma, surface charge density, charge per unit area, sigma. So E comes out to be sigma over 2 epsilon naught. So which is the required expression for electric field due to infinite thin sheet of charge. Infinite thin sheet of charge is given by E is equal to sigma over 2 epsilon naught. If sigma is constant, then electric field is constant. Now, if there is thick conducting sheet, special case, if there is thick conducting sheet, because charge always reside on the surface of the conductor. Charge always reside on the surface of the conductor. If conducting sheet is thick, then we have to consider charge on both the sides of the conducting sheet. So in that case, Q will be equal to 2 sigma S. Instead of Q is equal to sigma S, it will be Q is equal to sigma S. The total charge will be double. So therefore, in this question, putting Q is equal to 2 sigma S, 2 cancels, S cancels. So E is equal to sigma over epsilon naught. It means if there is a thick conducting sheet, so electric field will be half of the electric field due to infinite thin conducting sheet. So it depends upon the thickness of the conducting sheet. So this is electric field due to an infinite charge state wire and electric field due to infinite thin sheet of charge or infinite thick sheet of charge. So these are two applications I think ਤੁਹਾਨੂੰ ਸਾਰਿਆਂ ਨੂੰ ਬਿਲਕੁਲ ਸਮਝ ਆ ਗਿਆ ਹੋਊਗਾ ਔਰ ਇਹਨੂੰ ਇੱਕ ਵਾਰੀ ਫੇਰ ਰਿਵਾਈਜ਼ ਕਰ ਲਓ। ਆਲ ਦ ਬੈਸਟ, ਬੀ ਹੈਪੀ।